Okay, so Unit 5 functions, Lesson 10, Nonlinear functions, and the fair race portfolio. You're going to follow the instructions below to design a fair game for the new video game Animal Tracks. So the first step you need to take is you need to choose two different animals with different speeds. You can choose some that are on the table listed, or you can look up some of your own. Okay, so I'm going to do the kangaroo with 30. I'm doing the kangaroo with 30 and the ostrich with 40. Okay, so the race is fair if the two animals could finish the race in the same amount of time. So we're going to have to give some a shorter distance to travel. Okay, since the game is a video game, it does not have to be realistic. It can be any length and the animals can run at a constant speed. So write a system of two linear equations showing the distance that each animal can travel to model the fair race. Okay, so I picked the kangaroo, which is runs at 30 miles per hour, and the ostrich, which runs at 40 miles per hour. Now in my head, I'm going to try to figure out what is the least common multiple of these two. 30 and 40. 30 plus 30 is 60. 40 can't go into 60. Plus 30 is 90. 40 can't go into 90. 120. Oh, 120 can, 40 can go into 120 easily. And I know that 40 goes into 120 3 times. So we want them to run for the same amount of time. So that'll be that 3 hours that we just figured out, because 40 goes into 120 miles 3 times. So I need to figure out how many miles we need to give the kangaroo to make it a fair race. So in 3 hours, the kangaroo can go 90 miles. So I need to say 120 minus 90 gives me 30. So I need to give the kangaroo a 30-mile padding there. So the total number of miles and the miles per hour the kangaroo can run times the number of hours they run. Okay, now we're not giving the ostrich any help, and they run 40 miles an hour for so many hours. Okay, we know it's going to be 3 hours, but we need to show why that is true. So graph the system to prove that the two animals have an equal chance of winning the race. So there were my two equations, 30x plus 30 and then 40x. So you're going to graph these two. You're going to graph using the y-intercept. Remember that if there's nothing added or subtracted like there isn't on the second, it is 0, so it'll go through the origin. And then the slope is over here. That's that 30 and 40 that are squished up next to the x. Those whole numbers are always over 1, so you'll rise 40, run 1. Rise 30, run 1. Now I would like you to graph these on a piece of paper. Okay, you could send me a picture of what you graphed on paper, but you can also use a graph online, like one of the graphing calculators, if you want to get a image of that. But please send me both the picture that you graphed on your paper, just kind of a sketch, and then the accurate one on the calculator as well. That way I know that you know how to graph, but you also have the accurate picture there. And then make sure that you explain. So explain that that intercept that you find proves that that race is fair. So you're going to be turning in those equations, the graph, both on paper and on the graphing calculator if you choose to use that. If not, just your piece of paper, and then your explanation for that design.